today's messing around is accompanied by Void Stout from Full Geek Brew Lab in Winnipeg. They describe it as having tasting notes ranging from roast to smoke and notes of chocolate. Pretty sure I've had this one a few times before, and I'm pretty sure there's a reason that I keep buying it. So today I'm looking at these rechargeable lithium-ion batteries and the accompanying charger. These are LIR 2032, not to be confused with CR 2032. The CR 2032 are also a lithium-ion battery, but they are non-rechargeable. The LIR batteries are rechargeable, and that's why I chose these ones. That's also why I bought a charger with them. So I think I am going to take the charger apart. Well, I'll test it, see if it works, and then take it apart. And then I probably also should make sure that they are actually compatible with these LED candle lights that my wife likes to use around Christmas time. Because these are the reason that I bought them. They chew through 2032s, the non-rechargeable ones, in a couple of days. And it gets expensive replacing these things all the time. So let's just break one of these guys out of the package and see what kind of a charge it has from the factory. I'm hoping that it is not fully charged so that I can actually test the charger on them. Now the CR 2032, the non-rechargeable one, should be about 3.2 volts from new, and that's pretty much what it is. This guy, 4.1, which is reasonable, I guess, for a rechargeable battery. It is about the voltage you'd expect on a fully charged 18650. I think 4.2 is actually absolutely fully charged, but this one's pretty close. If I can keep my probes on the tabs of it. That higher voltage might actually cause some issues for these candles. Hopefully not. I'd really rather not have to modify them. Maybe I'll start by testing it on this one that I made using a little LED flame candle module and a switch and a battery holder there. It seems to work okay with that. It doesn't seem to be blowing it up, so that's good. So while it's under load, let's just see if it is pulling the battery voltage down some. Oh yeah, it's pulling it down to 3.8. Okay, that shouldn't cause a problem with those candles. You would think anyway. And when I switch it off, I assume it's going to be, closer to its... Oh, it's already pulled it down a little bit. So maybe the charge in these things is not all that significant, and I could probably get a little bit of charging into them, which is actually good because I did want to test the charger. So the charger came with a USB-C on it, which is nice, but it came with a USB-A to USB-C cable, which means it probably doesn't use power delivery, but that is an easy thing to test. So this is power delivery capable. Plug that in there. Ooh, nice blue lights, cool. But yeah, it's still at 5 volts, so it's not going to be doing power delivery, and that's just fine. Anyway, to look at this thing, I suppose I should have done that before I started playing with it, but whatever. It has 2 slots that claim to charge at 20 milliamps and 2 slots that claim to charge at 40 milliamps. Of course, these batteries, these cells, don't have any spec on them, so I guess I should look it up before I blow one up. Although 40 milliamps probably won't kill it, but yeah. Well, let's go and see if we can find a data sheet for a typical LIR 2032. I'm not going to find one for this brand, of course, because this brand is no name brand, but let's just go and take a look, see what we can find. Again, this isn't the same brand, but it's just one that I found. Seems like they hold between 35 and 40 milliamp hours. You charge them up to 4.2 volts, but their nominal is 3.7, which is reasonable enough. Charging method, there we go, 17 milliamps constant current and constant voltage up to 4.2. So constant current, constant voltage is standard lithium-ion charging. You charge it at the constant current rate until the current starts dropping off, at which point you charge it at the constant voltage mode until the current drops off to nothing, essentially. Discharge cutoff voltage, 3 volts. That could be an issue for these candles because they don't really cut off until the battery is too dead to power the LED. Although granted, it's an LED that probably wants at least 3 volts anyway, so that may not be an issue. The only interesting thing that I find down here, other than just expanding on the specs that we found up above, is 500 charge-discharge cycles, which for these, which were pretty cheap, shouldn't be an issue. And in the application that I'm using them in, that should last a decade or more, which is perfectly fine. So let's see what happens if I plug the battery into the 20 milliamp slot, making sure that I obey the correct polarity. Now the light turns from blue to, I'm going to guess, red. That makes sense. Actually, just for fun, let's see what happens if I put it into the 40 milliamp slot. Nothing. No light at all. Okay, I'll put it back into the 20 milliamp slot. Cool. Is that just a problem with the top one? Okay, that one goes red. Oops. That's what the problem is. Putting it in backwards. Well, that's annoying. I got the positive on the right for the low current and the left for the high current. So, yeah, okay, that one does work. I know why they did that. They did it to make the wiring easier inside, but it's not super intuitive when you're loading them up outside. Unless, of course, you look at them. I suppose that would do it. Anyway, positive side into there, into the 40 milliamps, and my charger is drawing negligible, unmeasurably low amounts. Right. I could probably even charge this off solar, you know. Let's get a few more of these in and see if we can charge multiples at once. So you should be able to, you would expect, do that. And yeah, that works. And how will it react if you do this? Oh, okay. Oh. Yeah, they seem to all work together. And with 3 of them actually charging and 1 of them not, still negligible amounts of current. Admittedly, these are all fairly close to their full charge, but regardless, that's not really what I wanted to. I mean, I wanted to test it to see if that would work, and that's cool. But I really like to see what's inside here. I hope it's something that actually makes a lot of sense and doesn't scare me. So there's no obvious screw holes. There is a bit of a gap along the side here, but it seems pretty tight. And I do notice there's a little dimple underneath the label. So is there a screw hole hiding under there? Yes, there is. So with that out, it just pops neatly apart. That's nice. Not much to see on the circuit board on this side. How does that come out? Is it just wedged in there? Seems to be. What's going on in here? Oh, this is going to be a pain in the ass. I'm not sure whether you can see down in here, but the connections are on a little spring that has a hooky bit underneath it. And when you push the battery in, it pushes it out of the way. How can I do this without jamming? Like that. But when I crashed it down, they kind of jammed. So I think what I'm going to have to do is kind of flip these up like that as I'm pulling them out and hope that I can get them back in later. So here is the circuit, and it looks like it's basically got 4 almost identical circuits on it. Each charger is independent, which is excellent. There's 4 different chips and 4 different LEDs and 4 different charging bays. Very neat. Also, it has the 2 5.1K resistors on the data pins, which means that this thing can work with smart chargers and tell them that, hey, there's something here, which is also nice. And it looks like this chip powers that one, this chip powers that one, this chip powers that one, and this chip powers that one. The LEDs are connected back to their chip via down through there. Okay. 1 resistor for each of the chips to set the current, the charging current, presumably, and then just a couple of capacitors. further evidence that those are the programming resistors for the charge control chip. That one is a 243, so what is that, 24K? And this one over here is a 393, 39K. And then again, where's the resistor? There it is. Yep. And yeah, so the two on this side are the 20 milliamp ones, and the two on this side are the 40 milliamp ones. What is that chip? Oh, you cheesy bastards. They have completely scrubbed the chips off, so we can't learn exactly what they are. That is annoying. Let me trace out the circuit of one of these and see if it matches any of the chips that we're familiar with. Hang on for a moment here. Oh, that was pretty straightforward. So as I suspected, there are just 4 copies of the same circuit on here, and they only have one change between the two of them. So at the USB connector, we got 5 volts and 0 volts, or ground, but there's no real ground, so let's just call it 0 volts, as expected. We have the 2 resistors for, again, telling whatever is providing the power that there is, in fact, a load on here. And they both go to 0 volts, as expected. 5 volts runs to pin 8 of all 4 chips. 0 volts goes to pin 3 of all 4 chips. Pin 1 is the output to the battery clip on all 4 of them. Pin 5 goes to the programming resistor, which then goes low. So on the 20 milliamp side, it's a 39K, and on the 40 milliamp side, it's a 24K. Other than that, pin 7 goes to the blue LED, and pin 6 goes to the red LED. There is no current limiting resistor on those. They just go up to the... Where do they go? They just go to 5 volts. Okay, as they're common. I guess we'll just put the LED common there. And that is all there is to it. I couldn't find any reference for these chips. I looked through the data sheets of a bunch of the common battery charging chips, conveniently located on Components 101, and this does not match the pinout of any of them. So TP4056, for example, is a very common one, but the pinout's not right. VCC is not over there on the one that we're playing with. It's over here, and the programming resistor is over here. It's not 4057 because I have too many pins. It's not that one because the package is wrong. It's not that one because the package is wrong. Again, I don't know. I went through a bunch here and also a bunch on a few other web pages that I found, and I could not come up with any that match. So I have no idea what these little anonymized buggers are. If you have any idea of anything that matches the pinout, and again, there it is, VCC on 8, 0 volts on 3, output on pin 1, programming resistor on pin 5, charging in progress LED on pin 6, and charge complete on pin 7. Let me know down in the comments. And then I guess the last clue would be that for 20 milliamp charging, you use a 39K programming resistor, and for 40 milliamps, you use 24K. Yeah, no idea what that guy is, but I'm not going to let that stop me. I guess the one other thing I want to check, oh, actually, I already tried it in there. So I'm going to assume that it will also work in my wife's fancy candles here. Oh yeah, I think you can see the flickering effect. Normally when you see a flickering effect on camera, it's not real, but this one is intentionally flickering for obvious reasons. And in a properly darkened room, these look quite convincing, actually. More convincing than the cheap little ones that just have a puck and that fake flame exposed. But when you can't see the flame thing directly, these little ones that I made up actually work pretty well. You may remember these modules that I got a year or two ago in a mail bag. They basically just have a bunch of LEDs underneath the hood here, underneath the little goopy whatever it is. There's a single 8-pin chip on there and not much else. Then it's just got a positive and negative voltage input. In the run-up to Christmas decorating, I quickly soldered these up onto some 2032 battery holders and just a salvage switch that I have in my collection. I don't always show every project that I'm building on the channel because, quite honestly, this thing is not worthy of a video on its own. But I thought it was pretty cool nonetheless. And like I said, when you can't directly see it, let me just turn that off. When you can't directly see it, it actually looks not too bad. The flicker that you're seeing is a lot more exaggerated than normal because you're seeing both the intentional flicker and the PWM. But to my eyes, it is much more of a normal candle looking thing, especially when you're looking at it, like I said, indirectly. But those two are going to work well, and hopefully I'll be able to keep up with the charge and discharge on them during the holiday decorating season next year. Well, I hope that was vaguely interesting. I think the hardest part is probably going to be putting this thing back together and getting all these spring terminals into their proper slots, although I think I should be able to manage. Anyway, yeah, questions, comments down below. I'll have a link to this charger down there as well. And actually, I'll probably put a link to these things if I can find one. Not the whole project, because I didn't do that on video, but, you know, just the module, because they are neat. They're about $2 each, unless you can find them on sale. Anyway, thanks for watching. Like I said, talk to you later.